I'm going to tell you a story about a mammoth, an island, a scientist, and a clock. Don't try to make any sense out of this now, we go slowly. So the mammoth, as you can see very clearly, it's not a woolly mammoth. It's a Colombian mammoth, and they have been distributed from the north of the United States all the way down south to Costa Rica. And they were huge. They had a shoulder height of around 4 meters, which is way larger than all of the living elephants or the woolly mammoth. The island I'm talking about is Santa Rosa Island. It's in Southern California and actually very close to LA. And the first step that we have to take is we have to get the mammoth onto the island. That sounds more complicated than it is because all we have to do is wait until the sea level drops. That happened regularly during the last few million years when we had glacials and interglacials. So during a glacial, the sea level would be lower, and the distance between the island and the mainland would be short enough for our mammoth to swim. And elephants and mammoths are very good swimmers because they have an inbuilt snorkel. So at one point, the climate becomes warmer, the sea level rises, and our mammoth is trapped on the island. And what happens when you trap a mammoth on an island? Maybe someone has tried. If not, I will tell you. They dwarf. They become smaller. And in our case, our mammoth in Santa Rosa Island dwarfed to just the shoulder height of 2 meters. Now you might say 2 meters, it sounds a lot for a dwarf. But if you remember that they originally had a shoulder height of 4 meters, then that's half their size. The next step that we need, so what we would be interested in is how quickly can that happen? But we don't even know which of the sea level low stands it used to colonize the island. So the next step that we need is the scientist. You might have guessed, I'm a scientist. And to be more precise, I'm a paleogeneticist. That means I work with ancient DNA. Ancient DNA is hundreds of years old, and it's damaged. It's fragmented into very short pieces. It's highly contaminated with all kinds of other DNA that we're not interested in, and it's very degraded. And all of this is worse in warm climates. So Southern California is not the place to be for a paleogeneticist. So when we got around 40 samples of bones and teeth of dwarf mammoths from Santa Rosa Island, I was game. I've been working on this together with a colleague, and we had an amazing positivity rate of around 2%. And for those of you who are not very good with math, that means we had 1 sample that contained dwarf mammoth DNA. And that's where the clock comes into play. And I'm not talking about a normal clock, I'm talking about a molecular clock. Because what we can do is we can compare our sequence to other mammoth sequences. And there are quite a lot of mammoth sequences out there. More than 4, I just didn't have the space because mammoths are very large. So we have around 200 mammoth sequences, mitochondrial sequence publicly available, and around 130 of them have temporal information. They have been dated, and we know when these mammoths lived. So when we compare our sequences, you can see our dwarf down here. You see differences in the DNA, substitutions, and they accumulate over time. And actually they accumulate in a relatively regular fashion, like the ticking of a clock. So when we use our temporal information from our big data set, we can actually calibrate the clock, and we can define the split between our island dwarf and the closest mainland relative. And this is the oldest possible date that they could have colonized the island. And why is all of this interesting? I might be biased, but we're talking about dwarf mammoth. But what does it have to do with you and me and today? And actually a lot, because what we're doing is we're destroying habitats. We're fragmenting them, and we're changing them in ways that are no longer recognizable to how they were before. That irritated me. That they no longer recognize how they were before. And I'm not just talking about elephants, but a lot of species. So it would be interesting to know if evolution can act quickly enough to have our current species adapt to these extremely changed environments that are like islands in a sea of human development. Thank you.